Alright, this is going to be a fairly short video on how to complete the square. So we've been factoring problems and solving problems by the square root method, and those have some limitations. We can't do every problem with those. However, the completing the square and also the quadratic formula will allow us to solve any quadratic equation. So if we have some quadratic equation, ax squared plus bx plus c equals 0. By definition, if it's quadratic, the a is not going to be 0. And completing the square will allow us to solve any of these. So kind of the strategy of doing this is we're going to move c to the other side of the equation. So we're either going to be adding or subtracting the number that doesn't have any x's on it, depending on if it's positive or negative is whether we add or subtract. We're going to divide by a if a is not 1. That makes completing the square a lot easier. The linear term is going to be b over a after we divide everything by a. And kind of the procedure is we're going to multiply it by 1/2. We're going to square it and add it to both sides. And when we do that, one side is going to be a perfect squared trinomial, and we'll factor that. The other side will simplify, so probably just adding some fractions or something like that. Then you're going to use the square root property to undo the perfect square trinomial. The square and the square root are going to undo each other. And then finally you're going to simplify your answer. So that means to reduce, or maybe you have a negative under a square root, so you're going to pull that out as an I. Maybe you can reduce the fraction or something like that. Alright, so let's do an example. We have 2x squared plus 8x plus 1 equals 0. So what we'll go ahead and do is we'll move c over to the other side of the equation. The c in this case is 1. And we'll subtract 1 from both sides of the equation. Okay. And then the next step is to divide both sides by a. If a is not 1, a is 2, so we're okay. So we're going to divide everybody by 2. And we'll go ahead and reduce. And I leave a little bit of room here just because I'm going to be adding something right here. Okay, now your b over a is 8 over 2, which is 4. So that's your linear term. B over a is 4. And then we're going to half it. And it looks like I didn't write a very good a here. Let's try again. So let's write a better a. There we go. So we're going to half it. So half of 4, square it, 2 squared is 4, and that's what I'm going to add to both sides of the equation. Okay, so the left-hand side is a perfect square trinomial. The right-hand side, I am going to find common denominator, so we have 1/2 plus 8 over 2 is the same thing as 4. So when I add them, I should get 7/2. Alright, and to undo that square, we're going to take the square root of both sides. Don't forget your plus and minus. One of our properties allows us to split square roots up with a fraction like this. And we just went over all that fussing about rationalizing the denominator, so here we actually get to use it. So to rationalize this denominator, we need to multiply by square root of 2. Okay, and then we'll come all the way up here. X plus 2 equals plus or minus square root of 7 times square root of 2, which gives me the square root of 14, divided by square root of 2 times square root of 2, which is the square root of 4, and the square root of 4 is 2. Okay, and then we're going to solve for x, so I'm going to subtract 2 from both sides, and 2 is the same thing as 4 over 2. So that's where this came from. So 2 is the same thing as 4 over 2. Okay. And our answer is nice and packaged, depending on what we're asked to do with this. Maybe they want us to split it up into 2 pieces. It just depends on what my math lab. But this is good enough for us here. All right, let's look at another example. So 4x squared plus 5x plus 6 equals 0. Our constant c, we're going to subtract 6 from both sides. Okay, and then we're going to divide by a, and a in this case is 4. So we're going to divide everybody by 4. And oh no, we get fractions, and that's alright. We can do this with fractions. So you have x squared plus 5/4 x equals negative 3/2 after we reduce. The linear term b over a is going to be the 5/4. And then our procedure says, okay, we're going to go ahead and multiply it by 1/2. And then square it. Okay, so when we multiply half times 5/4, that's 1 times 5, which is 5, over 2 times 4, which is 8. So we get 5/8 quantity squared. 5 squared is 25, 8 squared is 64, and that's what we're going to add to both sides of our equation. Okay. The left-hand side is a perfect square trinomial. One of the, I guess we can call it kind of the base of 25 over 64 is 5 over 8. 5 squared is 25, 8 squared is 64. Now if I take 5/8 and add 5/8, that gives me 10/8, and 10/8 reduces to 5/4. So this is a perfect square trinomial. We could check by foiling it, but we say it's x plus 5/8 quantity squared. So you could foil this and check if that really is the case, and it is. And it actually is, when we find that 1/2 b over a, that's always what's going to be in right here. Oh, that's always going to happen. Okay, now we got to do this fraction business on the other side. So LCD here is 64. 2 is going to go into 64 32 times. So I need to multiply 2 times 32, which is 64. Negative 3 times 32 is negative 96. So that's where these numbers are going to come from in just a second here. We need a common denominator. Okay, so we'll just rewrite, and then the right-hand side will have simplified, so we get negative 71. I hope I put that in. Okay, good. I put the negative in. All right, so what undoes the square root? I said that backwards. What undoes the square is the square root. So we'll take the square root of both sides. Don't forget your plus and minus. And we take the square root of a negative 71. Negative 71, there's not a whole lot we can do with it. It just hangs out as negative 71. We can't simplify it. However, the negative, we can simplify it. The square root of negative 1 is I. So that's where the I comes from. 71, we can't do a whole lot with. And then we have 8 in the denominator. If we subtract 5/8 from both sides, we could write it as one fraction because they all had a denominator of 8. Now they may ask you for like the real part and the imaginary part. The real part is going to be the negative 5 over 8. The imaginary parts are going to be the plus and minus square root of 71 over 8. You don't include the I, but it's there, and just in case they ask. Okay, so there's 2 examples. If you want like more, just all you got to do is ask them.